Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Juniper logical systems. Specifically within Juniper logical systems, in this lab we're going to be taking a look at how to use the logical tunnel interface option. And the logical tunnel interface option is only on specific Juniper routers. So not every Juniper router is going to have this option. So you're going to have to do a show interfaces or show interface terse to see if you have the LT interface. So what we're going to do is we're going to take a look at the concept of the logical tunnel interface, why you would use them, and for what reason. So just to summarize why you would use a logical system in the first place, what a logical system is going to allow us to do is to take by just having one physical router, we're able to break it up into multiple logical systems. So in this case, we have a lab, we have router 1, router 2, and router 3, but they all exist within one router. And so this gives us the power to create our own network topologies using multiple routers within one router. And then we're able to tie them together using the logical tunnel interface option. So essentially we can create any type of topology we want to. And of course there's a limit to the number of logical systems you can have within the Juniper, the Junos, or the Juniper operating system. And I think the max is either 15 or 16. So again, that might not be 100% accurate because Juniper's always looking to upgrade their Junos to be able to support more logical systems. So again, it's all limited to the router that you're on, and it should be noted that logical systems on a M-series Juniper router is not the same as on a J-series switch. So in the J-series, a logical system represents a class of service option. So it's not at all used in the same manner. And I know that some of the newer SRX, the Juniper SRX firewalls, they are including support for logical systems. Again, I don't think they're like the SRX 100s, the lower end ones. I think they're more higher end SRXs. So that support is coming out soon. So what I'm going to do in this lab is I'm going to lay a solid foundation of how to use the logical systems using the LT interface option. So there's other ways you can use logical systems, but in this lab, this is Juniper Logical Systems Lab 1, we're going to take a look at the LT option. So let's go ahead and get into our Juniper router. And one of the first things we want to do is, again, if I go back to our network topology, we have router 1, router 2, and router 3. So what we're going to do is on our physical Juniper router, again it's named the Juniper Lab router. Under the Juniper Lab router, we're going to create logical systems R1, R2, and R3. And then within R1, we're going to create the logical tunnel interface of 120, and then we're going to specify different units which are going to connect to different routers. So we're going to have a logical unit of 12 on R1 that is going to connect to the logical unit of 21 on R2, and we're going to see that there's a couple of different commands that we have to apply to get this to actually work. So not only do we have to assign it an IP address under the unit, in this case the inet 0, so this is going to be our IPv4 address family, but we're going to have to bind the units together with the peer unit command. Also, we're also going to be using the encapsulation command to specify Ethernet encapsulation all across these links. So let's go ahead and get into our router. And the first thing that we're going to do We're going to go under configuration mode, and then we're going to create router 1 as the first logical system. So we're going to do the command set logical systems, and then you can see that we have the option for our logical system name. So here's where we're going to name it R1, then we're going to do space question mark, and then our next thing that we're going to do is we're going to use the interfaces command. So we're going to do set logical systems R1 interfaces, and then you can see that we have the option to include an interface name. So in this case we're going to be using LT-120. So again, depending on, just do a show interfaces or show interface terse on your router, your physical router, to see what logical tunnel interface your router is configured with, because some of them vary. So in this example we're using the set logical systems R1 interfaces LT-120 statement, then we'll do a space and do a question mark. You can see that we have the logical interface that we're going to create with the unit command. So in this case we'll do, the first thing we're going to do is, if we take a look at our topology, we'll do unit 12, and this is our connection from R1 to R2, logical system R1 to logical system R2. So again we'll do unit 12, and then again we're going to use the protocol family command, so we'll use the family command and then space question mark, and then we're going to use the inet statement for our IPv4 parameters. So we'll do inet and then space question mark and then use the address command. So again, this is where we're going to put in the IP address of the logical tunnel logical interface. So we'll do 12.12.12.1, and then again this is just going to be a /24. So just by doing that command we are not done. We have to also set the encapsulation. So we'll do the command set logical systems R1 interfaces LT-120, again for the same unit, which is 12, which is our connection from router 1 to router 2. And then we're going to specify the encapsulation, or if I just do a question mark after unit 12, you can see that we have the encapsulation, our logical link layer encapsulation option. So we'll do encapsulation and then follow that up with Ethernet. So again, you can do frame relay and other types of encapsulation if you want, but for this example we're just going to use Ethernet. So now that we have those two statements under our logical systems R1, we're going to end that with the last statement, which is the set logical systems R1 interfaces LT-120 and unit 12. And the last and most important statement that we're going to use for the logical tunnels logical systems lab here is the, if we do a question mark, we're going to use the peer unit statement. So again, this peer unit statement, in this case we're going to do peer unit 21 and then hit enter. Now if I go back to the diagram, I'm using peer unit 21 because that tells the logical system what peer unit to bind with or to be a part of. In this case we are going to be using the logical unit of 21 from router 2's logical tunnel 120 interface to peer with. So without that statement we would not succeed, and I'm going to show you that. Now if I do a commit check just to make sure everything works, we see that the configuration check succeeds. So now let's go ahead and add our logical systems for R2. First, before we do that, we can do the command show logical systems and hit enter, and you can see now that we have created the logical system of R1. We have an interface logical tunnel 120 with the unit 12 with the encapsulation of Ethernet, the peer unit 21, and we have our IPv4 address of 12.12.12.1/24. So R1 at this point is complete in the sense of its connection to R2. So now if we go ahead and try to configure our router 2 logical system, we'll do the command again, set logical systems, and then we're going to create it. So now you can see that we have R1 show up where before we just had the name option. So now we can do stuff under R1 like we did before. Under this, we're going to create R2 as the second logical system. So we'll do set logical systems R2, and then interface is going to be LT120. LT-120. Then we're going to follow it up with the unit. And the interface's logical unit. So in this case, our logical unit, our logical interface for the logical tunnel 120 from router 2's perspective is going to be unit 21. So again, if we go back to our network diagram, that makes sense because we are on router 2 now, and we're setting the unit of 21. So again, router 2 to router 1. And now we'll specify the family inet and give it the address of 12.12.12.2, and then follow up with the subnet mask of /24. So now if I go ahead and again I'm missing my encapsulation statement for R2, the logical system of R2, and I'm also missing the peer unit statement. So if I go ahead and try to do a commit check, let's see what happens. And you can see that we're getting an error when we look at the check that says that the peer unit needs to be configured for the logical tunnel interface. So it's telling us, no, we're not going to allow you to perform this function because there's no peer unit specified under the logical system R2 for the interface LT120 for unit 21. So our next step is to do the set logical systems R2, interfaces LT-120, and then unit 21. And then if we do a space question mark, you see again where we have the peer unit option. And then again, this is the binding which binds R2's logical system, the LT120 unit 21, to the peer unit of 12, which is, again, if we look at our diagram, which is R1's LT120 logical unit 12. So this is what builds the connection within the logical systems from R1 to R2. So this command is very important when configuring logical systems from a logical tunnel point of view. So we go ahead and hit enter here, and then now if we do a commit check, let's see what happens. And now you can see that it spits back an error at us saying that the unit 21 under logical system R2 needs encapsulation to be specified. So again, like I said before, you need 3 key things for the logical system connection from one logical system to another. You need to specify an IP address, you need to specify the encapsulation, and then you need to specify the peer unit. So let's go ahead and do the set logical systems R2 interfaces LT120 unit 21, and then we're going to set the encapsulation to Ethernet. So now if I go ahead and do a commit check, you can see that our configuration check succeeds. So now we can do a commit, and then we'll go ahead and quit out of configuration mode, go back to operation mode. So in this case, if I do a show route logical system and do R1, you can see that I have two routes in my routing table for the logical system R1. So this makes sense because from R1's point of view, it only has 2 routes in the routing table, and they're both the 12 network. We have the host, we have the IP address of the local interface, then we have the directly connected subnet 12.12.12.0. So I can also do the command set CLI and then do the logical system option, and then this will allow me to log into one of the logical systems. So I can do set CLI logical system R1, and then as you can see our prompt has changed to root at Juniper_lab R1. So now if I do a show route from here, you can see that I have the networks, the 12 network. And also if I try to ping from R1, if I do a ping 12.12.12.2, you can see that it is successful. So we'll also do a ping, we'll just do a rapid count 1000, and you can see that our ping is successful. So again, just another way to take a look at your logical systems. So now let's go ahead and go back to our diagram. We have also a logical system R3. Let's go ahead and create the logical system for R3. So if I do the command, if I go under configuration mode, and we'll do the command set logical system, and then now if I do a question mark, you can see that I have R1 and R2. Let's go ahead and create R3, and then we'll give it the interface, again the logical tunnel 120, and then again the unit for router 3, or the logical unit we're going to be using, is going to be unit 31. So again, this tells us that it's going from router 3 to router 1. Again, on router 1's point of view is going to be unit 13 from router 1 to router 3. So we'll do unit 31, and then again this is going to be for the family iNet with the address of 13.13.13.3 with a /24 subnet mask. Let's go ahead and set. Let's do the next statement, which is set logical systems R3, interfaces LT120, unit 31. Then we'll specify the encapsulation of Ethernet. So now again, if I do a commit check from here, it's going to spit back an error saying that the peer unit needs to be configured. So again, in this case, from router 3's perspective, router 3 is going to be peering with the logical unit of 13, which is connected to the logical system R1. So we'll do the command set logical systems R3, interfaces LT120, again unit 31, and then we'll do the peer unit of 13. So now if we do a commit check, that should work, and we can see that we are successful. So if I were to go ahead and commit and quit and get out of the configuration mode, now if I do a show route logical system R3, you can see that we only have a /32. So if I were to do a ping from logical system R3 to 13.13.13.1, you can see that we have the option, or we're getting back no route to host. So again, this is because we have not created the logical tunnel unit, or the logical unit on the other side, and that is from R1's logical system. So let's go back. Again, if we look at that from our lab point of view, unit 13 we did not create on R1. We only created unit 12 going from R1, the logical system R1, to the logical system R2. So let's go back into our router, and we'll do the set logical system R1 interface LT120. Again, the unit is going to be 13. Again, this is router 1 to router 3. Again, the family is going to be iNet for the address with the address of 13.13.13.1/24. Also, we can't forget we have two more important commands. We have the peer peer unit statement. So let's do the set logical systems R1 interfaces LT120 unit 13 family iNet. We already put the IP address on it. We'll do the unit 13, and then if we do a question mark, we're going to be using the peer unit statement. So again, the peer unit is going to bind the logical unit 13 from R1's point of view to the peer unit, or the peer logical interface of 31, which is connected to the logical system R3. So again, if I try to just commit and check out of here, what's going to happen is we are going to get an error saying that there's no encapsulation set. So we need to set the encapsulation next. So we'll do set logical systems R1 interface LT120. Again, for unit 13, we're going to set the encapsulation to Ethernet. So now let's go ahead and commit, check that, and we can see that our configuration check has succeeded. So we'll go ahead and do a commit and quit, and we'll go back into operational mode, and then we'll try the ping again like we did before. We try to ping from logical system R3 to 13.13.13.1, which is the IP address attached to the unit 13 logical system on R1. So now if we try to ping, you can see that we are successful. So let's do a rapid just to show you. Count 1,000, size 1,000. So as you can see, that we are now successful. So what we have done is we have created a simple network topology that is all within logical systems within one Juniper router. So again, this gives us a lot of power and features that we are able to do with logical systems. We can do routing protocols such as static routing. We can do static routing. We can do routing protocols such as RIP. We can do OSPF. We can do ISIS. We can do BGP. We can do MPLS. We can do MPLS VPNs with logical systems. So there's some limitations such as class of service, quality of service. Some of those, of course, rate limiting, policing, aren't going to work as designed because we are using logical interfaces and we don't have physical interfaces for buffers, for quality of service and other things. So, but just for the purpose of practicing and learning how to configure the Juniper commands and protocols, logical systems will allow you to do pretty much everything that you need to do. And so again, this is Juniper Logical Systems Lab 1, and in this example we showed you how to use the logical tunnel interface option. What we did was we created a connection first from router 1 to router 2. We created logical system R1 and gave the logical tunnel 120 interface the logical unit of 12. Likewise on router 2 we did the same thing and created a logical unit of 21 for the logical system R2. On the connection from R1 to R3 we created the unit 13, and we created the logical unit 31 on logical system R3. So again, there's three main statements you need to have. If we go back to our configuration, if I just do a show configuration logical systems R1, let's take a look at R1's configuration. The three statements that we need to be successful to create a connection from one logical system to another using logical tunnel is we need to specify an IP address, can do IPv6 if you want, but we have to have a connection at layer 3. And also we had to specify the encapsulation type. In this case we used Ethernet. You can use other types of encapsulation, for example frame relay. And then also one of the most important commands that we need is the peer unit. So this is going to bind the logical unit. In this case unit 12, we had the peer unit of 21. So this was the binding between the unit 12 from the logical system R1 to unit 21 on logical system 2. So if you have those three things, what you can do again, you can go into, we showed you how to do the set CLI logical system R3, so we can log in. So it's like we're logging into the logical system R3. Then we can do a show route. We can take a look at the local routing table. Again, as you configure routing protocols and stuff, this will look a lot, there'll be a lot more routes and stuff in there. So we learned a lot in this lab. Again, this is Juniper Logical Systems Lab 1 using the LT interface option. So thanks for watching, and I hope to see you in the next one.